All right, I'm back with the components we're going to need. The first thing we're going to need is an LED. This is a little component made out of silicon, and its function is that when you pass current through it, it lights up. So this one happens to be green, but you can buy them in red or blue. You can buy them in a lot of different colors that you might like. This clear thing on the top, it's really just plastic. It just spreads the light out, makes it a little easier to see. That's all that is. Okay, now the two leads you see on the end, they're different lengths. One's a little bit longer than the other. The longer one is the positive side. So whenever we hook it up, we're going to make sure that that one is closer to 5 volts and the shorter one is closer to ground. And you'll see what I mean when I hook it up. Diodes are a kind of device that it makes a difference which way you plug them in. And you can plug them in backwards. And it's not going to damage it if you plug it in backwards, but it's not going to work. So we're going to make sure and plug it in right when we plug it in. Okay, here's my circuit board. And what I'm going to do is I'm going to take the short lead and I'm going to plug it in to 0 volts. So let me get the other lead. The other lead's stuck in accidentally. Okay, so there you go. You see what I've done is I've plugged that short lead. You can see a little better. There you go. I've plugged that short lead into the blue line right there. That's the same thing as connecting that side of the diode to 0 volts. Now I'm going to take the long end, the long lead of that diode, and I'm going to plug it into a hole. Now it's not particularly important what hole I plugged it into. I put it over on this edge of the board because we're going to do several of these circuits later on, and we're going to need the space again in the middle of the board, so I'm kind of keeping these out of the way. Well, this isn't going to do anything yet. I've got one side connected to ground. I've got the other side connected to really nothing. If I want this LED to light up, and I need to put current through it. And to get current through it, I need to have one side connected to 5 volts, and I need the other side connected to 0. Because current always flows from higher voltages to lower voltages. So if I want current to flow through something, I put one side at a higher voltage, and I put the other side at a lower voltage. And there'll be a lot more talk to, when you get to do circuits 1, where they'll talk a whole lot more about that. But for right now, that's about all we need to know. So I need to connect this to power somehow. I'm going to take this resistor. Oh, this is the next component that we need to know about. This is a resistor. It's just a little piece. This one's made out of some kind of carbon material, and it regulates the amount of current. So you put voltage through it, and then you get a certain amount of current. It's Ohm's law, V equals IR. And so the value of this resistor has been chosen specifically so that when I put it from 5 volts to this diode, and I divide by that resistance, which in this case is, this is a 330 ohm resistor, the current's going to be just right. It's going to be about 10 milliamps is what it's going to come out to. And again, all those numbers and formulas, you're going to hit those in circuits 1, so don't get too uptight about them right now. Okay, I'm plugging this resistor in, and there we go. Now you see that I plugged one side of the resistor in to the same set of holes that I plugged in that diode. So right here at this node, right where those two lines come together, you can see the diode, and you can kind of see it's not focused all that great, but you can see that the lead of the diode and the lead of the resistor are in that same row of pins. And that's what's got them connected together. Now I took the resistor and I put it on the other side of the trench. That's important because remember that trench separates the two halves of the board. So if I were to plug this resistor in on the same side, that wouldn't work because both edges of the resistor would be connected together. That's not what I want. I want this side to be separate, and so I plugged it into the other side. Now I could have taken this side of the resistor and just plugged it straight into 5 volts. I'm going to do that for a second. Okay, see, I plugged this side of the resistor into 5 volts, and look what happened. The LED lit up. So to give you a rundown of what's happening here, I've got 5 volts on the red line. The fact that there's a voltage difference between the red line and the blue line makes current flow from higher to lower. Voltage is a little bit like height, like gravity. It makes things move. And in this case, voltage makes electrons or current move, actually. And the way that the current moves is through these devices. So it goes through the resistor, connected to the diode, through the diode, and down to ground. And then you say, well, how does it get back up to the top? Through the power supply, right? The power supply is like the pump in this circuit. So it's constantly pumping current. You can think of current as kind of like water. Currently pumping current through both those devices, back through the power supply, and over again, over and over and over. Okay, and again, the purpose of this resistor is because if I were just to take the diode and put it straight from 5 volts to ground, current would flow through it, because again, the voltage difference between the red and the blue, the 5 volts, is wants to push that current through, and the diode would let it. The problem is that it would push too much current through, so much current that it would burn the diode out. So we put a resistor in there to make sure that it's the right amount. It's called a current limiting resistor. It limits the current to just the right amount. In this case, I've chosen 10 milliamps because you can see the LED glows nice and bright at 10 milliamps. If I wanted it to glow brighter, I could put more current through it. If I wanted to save some current, there's no really need to in the lab, but I could run a little bit less through it, and the diode would just be a little dimmer. Okay, now this is an LED circuit, but it's not as useful as what it could be. What I'm going to do is move this resistor back to where I had it before. You see now the LED's off because there's no closed path. There's no way that this end of the resistor can get to the 5 volts. So what I'm going to do is I'm going to take a wire, and I'm going to plug this wire. I happen to choose white. You could use any color. I'm going to take this end of the wire, and you see I plugged the wire in here next to the resistor. So if I take this wire and I connect it to 5 volts, like that, you see the LED lights up because now I got 5 volts through the wire, through the resistor, through the diode, back to ground. That's the path. Now, this is exactly what I had before, really, when I had the resistor over to the red, but this has got a little extra function to it. Look what happens when I take that wire and I move it to blue. The LED goes off. Now, why is this? Well, the reason is because this is 0 volts. There's no difference between 0 volts and 0 volts. It takes a voltage difference to make current flow. So since there's no voltage difference between these two, it's like water not running. It's like if you put water on a flat surface. It doesn't go anywhere, right? There's no gravity. There's no hill to make it go. So that's what's happening here. Now you might say, well, then why'd you build it that way? It's not a very good circuit, right? Why'd you build it like that? Well, because what we're going to do later on is we're going to have signals that are sometimes 5 volts and sometimes 0. And we want to test and find out which one it is. So we're going to take this wire and we're going to plug it into something we don't know. And if we plug it into that place and it's 5 volts, the light's going to light up. And if we plug it into something and it's 0 volts, the light's not going to light up. And so we're going to use this as a test circuit. It would really be called the logic probe. Our logic values are going to be 1 and 0. 1 is 5 volts, 0 is ground. So when I take this logic probe and I plug it into the output of a chip, if it's a 1, the light's going to light up. And if it's a 0, the light's not going to light up. All right, so that's our first circuit with our breadboard.